corporates, government agencies, as well as startups in Singapore. So for first-timers here, I do see a few familiar faces though. Thank you for joining us again. For first-timers, why we actually want to do CS seminar. So CS seminar in short is computer science seminar. What we aim to do is actually to establish a collaborative exchange between academias as well as industry players. We want to share the forth-running research that's happening within the research world to bring knowledge and insights about how not only AI can change your lifestyle, but also change your business application and make things better for you. So this is the fourth of the running series. The first one in data mining, we have Professor Tang Ji from Tsinghua and so on and so forth. As you can understand, the previous seminar was a little bit more technical in nature, but this time around we decided to mix both technicality as well as business application so that it resonates better with how real-life application is done. So CS Seminar 4 is about explainable artificial intelligence. And one of the things that if you are exposed to AI is that it lacks transparency as well as explainability. In short, if you are doing sales prediction modeling or market impact modeling, you will be able to get a good prediction on what's going to happen. But have you ever wondered what is the factors that's impacting these results? So a lot of the time there is this issue called black box syndrome, black box phenomenon, and that is the lack of explainability in how a prediction is formulated. So XAI, in short, is actually done to solve this issue. The vision is to solve this issue, but factually, it only can reduce the amount of inaccountability there. We want to, the takeaway that we would like to bring across in this seminar is firstly, we want to understand what is XAI, the challenges involved in running XAI modeling, and what is the forth-running research in this topic. The second takeaway that we would like is to examine some of the desired results in predictive modeling and the potential concepts to actually achieve that. And last but not least, we want to investigate how XAI is actually applied in a business application, particularly within the personal care industry, and then to see how we can derive evidence-based market insights from using XAI. So a quick overview of today's topic. So we have Professor Chua from National University of Singapore. So Prof. Chua is also the chair professor in NUS as well as a visiting professor from Tsinghua University. He is also the founding dean of NUS Computing Science from 1998 to year 2000. We also have Prof. Sri Peng representing Tsinghua University. So he has published more than 100 papers, and they are all mostly award-winning papers. Recently, there's also a IEEE best paper that was being awarded to him as well. And last but not least, we have Rachel. Rachel is a practitioner. So what we meant by practitioner is applying the technology to discover something within the business application. So Rachel has been working in the research agencies for more than a decade, and so her purpose in this discussion will be to elaborate how the data analytics combined with XAI can derive more market insights. So you saw that screen there, and we will actually like you to pay attention to the presentation there, because there will be a quiz later on. Just kidding. So it's more of a survey for you to share with us what you felt about the seminar so that we can improve it for CS Seminar 5 and so on. So without further ado, let me do a more detailed introduction about our first speaker, Professor Chua Tak Sing. So Professor Chua's topic will be about explainable AI. So existing AI models have limitations on trade-off between interpretability and accuracy. So what is the current state of the art in terms of approaches towards XAI? That's number one. We also want to understand how prior domain knowledge, information theoretical principles, and adversarial algorithms are used to interpret, to achieve interpretability. So besides the profile that I mentioned earlier, Prof. Chua is also the co-director of Next Research Center. He is the recipient of 2015 ACM Achievement Awards, as well as being the chair of steering committee of ACM International Committee. In short, he is a very distinguished researcher. So, he is also the co-founder of two technology startups, one VSense and one 6Estates in Singapore. So if you may join me, let's give Prof. Cha a round of applause to welcome him for this talk.
I need to figure out how to do this first, yeah. Anyway, thank you very much for coming. I guess today is nice actually. It's quite nice and cool, but except that it's a bit wet. Yeah. So it's actually good to see so many people here. Yeah. So I'm used to giving talk to technical audience. So I guess it's the first time that I'm giving talk to kind of business audience. So I guess if there's any part that I go too fast or anything, just stop me anyway. Yeah. So the topic is kind of explainable AI, which by now is actually a standard topic in research now. I guess if you go to any research lab and anything, everyone will tell you that their research topic is on explainable AI. So I thought it would be a good time for us to basically look into it and say, and basically examine what exactly is explainable AI. Right? So I'll kind of go through a bit of background, a bit of motivation of why we want to do this, and then go deep into our explainable framework, and then followed by summary. Yeah. So I'll first of all I just give a very brief introduction to AI. I think a lot of these probably you guys already know. I think in the 1950s, I guess the first event, I don't know whether you can call it AI or not, but I guess it's Alan Turing, who invented a British mathematician who actually started this whole so-called Turing machine. The computing actually started in 1950. And then I guess in the 1960s, again, we are basically fixated with logic, semantic web and things, semantic relation graph and things like that. So actually, at that time, a few companies that are still around, for example, so actually, this whole thing is trying to kind of use logic to build out the whole knowledge structures and then use that to infer the knowledge. It's actually actually something that we should look into, but of course this approach actually doesn't scale, right? And then actually after end of 60s, actually nobody talk about it. Actually, if you think about it, in the 60s you have schema, you have frames and things like that. Those are the so-called very deep knowledge representation, and actually now people are still kind of beginning to actually re-examine that to see in the light of deep learning, can knowledge graph, can all these traditional knowledge representation scheme play a role? Of course it can. Yeah. And of course in 1970s, because things are not scalable, and then we actually enter into a winter. And of course, this is a nice picture anyway. Actually, I don't mind being in the winter. Actually, we can actually more relaxed. Yeah, and then and actually towards the end of 70s, early 80s, I don't know whether you remember the Mycin systems, the rule-based systems. Actually, Feckenbaum of Stanford. I think I remember it very well because that was the time I came back to Singapore, and that time the rule-based system was really hot. And the main applications of the Mycin system is actually medical diagnostics. So everything is encoded in the rules. You can actually explain, and actually you can give diagnostics, everything to all the medical problems. But again, the problem is scalability. It doesn't scale, right? And so we kind of enter into another beautiful winter for AI again. And then towards the end of 90s, I don't know, I think most of you should have working by now. Towards the end of 90s, actually, neural network was really hot. Yeah, everyone are talking about neural network. Of course, that only lasts about 4 or 5 years. I think the reason is that probably at that time, we do not have the technology to basically scale it up. So we cannot do anything deeper than a few layers. And also, we don't have convolution, we don't have all these things. So actually, it doesn't really learn and scale very well. And of course, we kind of, in time of crisis, you always fall back to something nice, right? So another winter. And then of course, at the end of, towards the end of 2000, I think a few things happened. I think later I'll just say, first of all, data is available, computing power is actually plentiful, so we can actually do a lot of things that are not possible then. And also, I guess this is Deep Blue. Deep Blue is not based on deep learning, right? So a few key events, Deep Blue beat the human, which is something unthinkable. But Deep Blue is actually not based on